So, good day, everyone. Good day, sir. Welcome to our group, and our topic was all about dependent sample t-test. And let's go.
Good day, sir. I am Michelle Calio del Rosario, and I am the first presenter of our presentation, which is dependent sample t-test. So, what is dependent sample t-test? A dependent sample t-test, also known as per t-test, is a statistical test that compares the mean of two related groups to determine if there's a statistically significant difference between the groups. So how to use per t-test? When each subject has a pair of measurements which as a before and after the score, a per t-test determines whether the mean change of their pairs is significantly different from zero. This test is an inferential statistics procedure because if there's uses sample to draw conclusions about populations. So there are two types of Faraday test. First one is hypothesis and second one is assumption. Faraday tests have following by the hypothesis. Null hypothesis. The mean of the fair differences equals zero in the populations. The second one is alternative hypothesis. The mean of the fair differences does not equal zero in the population. And the assumption is have five classification, which is the first one is independent subjects, which is measurements for one subject does not affect measurements for any other subject. Second, paired measurements. Each paired measurements must have obtained from the same subject. Next is normally distributed differences, which is the measured difference are normally distributed. And dependent variable, which is the dependent variable is measured at incremental level, such as ratios or intervals. Last one is related groups. The dependent variables must consist of two related groups or matched pair. So for example, we have data set example, which is first one is subject, then pre-test and post-test. So imagine we have a training program and administer a pre-test and post-test to the same sample of students. Consequently, each student has a pair of test scores. We need to determine whether the average change for the pair of scores is different from zero. So if we're going to interpreting the result, pre-test and CI pre-test and post-test. So the pre-test is the number is 15, mean is 97.06, standard deviation 10.31, and the mean is 2.66. Si estimate is muna siya yung, let's say that the average. Post-test number 15, mean 107.83, and standard deviation is 13.25, and the average is 3.42. Then differences 15, then negative 10.77, then standard deviation 11.17, then the average is 2.88. If you're going to calculate that in the sample test, the mean difference is p-value equals negative 3.37 and p-value equals 0.002. because that's the result of the CI for the mean difference, which is we calculate that negative 16.96 then times minus 4.59 and the result below. And the explanation is the output indicates that the mean for the pre-test is 97.06 and for the post-test is 107.83. The average difference between the pre-test and post-test scores is negative 10.77 because 97.06 minus 107.83, the result is 10.77. Then if the p value is less than your significance level, the difference does not equal 0. So kung dili mo babasa point 0 ang result is dili siya kuan kada significance level. The next one. So we will interpreting the output to more explanations, to more understanding. So mean difference, the average difference between the paired values ig post minus test minus pre minus test. Then ang t statistic indicates how far the sample mean difference is from 0 relative to the variability in the differences. Then p value determines if the result is statistically significant. Then when should we use it? So when we use, kailan natin ito gagamitin? The dependent t-test can be used to test either a change or a difference in means between two related groups, but not both at the same time. Whether are you measuring a change or difference between the means of two related groups difference your study design.
Hi everyone, I'm Reajean Caguindangan. I'm going to discuss that you should use as dependent sample t-test when, number one, the samples are related or paired. Before and after studies, measuring the same group of people or item before and after an intervention. Example, testing blood pressure before and after a treatment. Another, match paired design. That match pair design. Participants are matched based on certain characteristics. Example is twins or matching participants by age and gender. Then repeated measures. Measuring the same group under different conditions is their example is testing reaction time under two different lighting conditions. And number two, the dependent variables is continuous. The data may being compared should be measured or on an interval or ratio scale. And its example is this test scores, weight, and time. Number three, the difference are approximately normally distributed. The test assume that the difference between paired observation are approximately normally distributed. If this assumption is violated, especially with small sample sizes, a non-parametric test like the well-caution signed rank test might be more appropriate. You are testing whether a new study technique improves students' performance. You record their scores before using the technique. Since the two scores came from the same group of students, a dependent sample t-test is appropriate. What is required to perform a dependent t-test? To perform a dependent t-test, you need one dependent variable that is measured on an interval or ratio scales and one categorical variable that has only two related group assumptions. That data must meet certain assumptions in order for a dependent t-test to give a valid result. Example, you should use a dependent t-test to understand whether there was a difference in smokers' daily cigarettes consumptions before after a 6 weeks in hypnotherapy program. In what data we can apply this? A dependent sample t-test can be applied to data that meets the following condition. First, paired or related data. The data should come from two related samples such as before and after measurements on the sampled individual. Example, weight before and after a diet program. Repeated measures on the same subject under the different condition. And their example is test performance under quite a noisy environment. Match pairs two related groups such as twin or individual matches by a characteristic like age or experience. 2. Continuous dependent variable. The dependent variable, the one being measured, must be continuous and measured at the interval or ratio scales. Example include test scores, reaction time, blood pressure, weight. 3. Normally distributed differences. The differences between paired observation should be approximately normally distributed. This assumption becomes less critical with larger same sizes due to the central limit theorem. For small sample sizes, if normally is violated, a non-parametric test like the Wilcoxon sign-wrong test may be better. 4. A sample size between the t-tests are typically used when the sample size is not very large but should have at least 5 to 10 pairs of data points for meaningful result. 5. No significant outliers in differences. Outliers in the differences between paired measurements can distort the result of the test. Use visualization like box plots or statistical methods to check for outliers. Example data for dependent t-test. In my example dependent t-test, I have 5 participants and I have their pre-test score and post-test scores. The first participant, his pre-test score is 85 and his post-test is 90. The second is his pre-test is 78 and his post-test is 82. The third is 92 in the pre-test, 94 in the post-test. The fourth, 88 in the pre-test and 87 in the post-test. And lastly, the fifth, his pre-test is 75 and the post-test is 80. The score for each participant are paired pre-test or pre-test versus post-test. The test checks whether the main difference between the pre-test scores and post-test scores is significantly different from 0. And that's all. Thank you.
So good day everyone, good day sir. I am Marchky Devinagracia, the third reporter of this group. So how should use in Jamovie? Using a dependent sample t-test in Jamovie is straightforward. So follow these steps. So step 1, open Jamovie software. And step 2 is load your data, import your dataset into Jamovie. You can drag a drop and drop a CSV or SAB or other supported files formats into the workspace. Ensure your data has 2 columns, one for each paired measurement, example, pre-test and post-test. So next, so number 3 or step 3. So access the t-test menu. So go to the analysis and menu to the top of the screen. So select t-test, paired samples t-test. Step 4, select the variables. So number 4 or step 4. So select the variables. In the analysis window, drag your 2 related variables, example, pre-test and post-test, into the prepared variables box. So you can open your Jamovie, will treat this as data. So, step 5. Check assumptions are optional. Check the descriptives box to get summary statistics, means standard deviations, for each condition. Use the QQ plot or Shapiro Wick these options to check for normality of the differences. So, step 6. Review results. The output table will show. So the mean difference between the two groups, the t-statistics, degrees of freedom, and p-value. Confidence intervals for the mean difference. So step 7, interpret the results. If the p-value is less than your significance level, commonly 0.05, there is a significant difference between the paired means. If the p-value is greater than 0.05, you fail to reject the null hypothesis, indicating no significant differences. So let's move on to this topic. What are the conditions? The conditions are assumptions for performing a dependent t-test in the movie or any statistical software are essentials to ensure the t results are valid. So I have here 7 examples, I think 7 examples. So number 1 is paired or related data. Number 2 is continuous dependent variables. And number 3, normally distribute differences. Number 4, no significant outliers in the differences. So number 5, scale the measurement consistently, scales or measurement consistency. Consistency. Number 6 is sufficient sample size. Number 7, independence or pairs. So let's move on. So how many group of data and what type of data and level of measurement? So when using a dependent sample t-test, the type and structure of the data as well as the level of measurement are critical to ensure the t-test is appropriate. So first, how many groups of data? So number 2, type of data. Number 3 is level of measurement. So number 1, how many groups of data? 2 groups of data paired or related. Duha na day sila. So you need 2 sets of measurements. So example, pre-test or versus post-test. These groups must be related because each observations in one group corresponds to one observation in the other group. So example, measuring the weight of participants before and after a diet program. Comparing students' test score under 2 different teaching methods. So this example is nag-measure siya sa weight or sa participants before nag-diet sila. And sa comparing student t-score under different teaching methods, mao din sila tig-compare sa mga test underscore difference. Okay. Number 2, type of data. The data should be quantitative numerical. Both groups should measure the same dependent variables. For example, t-scores and reaction time and weight. Example, numerical t-score, example 78, 85, and 90. Reaction time is in seconds, example 1.25, 1.37, and 1.45. So number 3, level of measurement. The dependent variables must be measured at the interval or ratio level. Interval level. The variable has manifold differences between values but no true 0 point. Example, temperature in Celsius. Ratio level. The variable has manifold differences between values and a true 0 point exists. Example, weight, time, and scores. Inappropriate data. Categorical data, nominal or ordinal, cannot be analyzed with a independent t-test. For example, yes or no. Responses are like, scales ranking 1 to 5 are not suitable unless converted to numerical scores. So next, So I have here example data pretest or participant pretest and score post test. So mao din siya Ate, no, dit na. Wata ka mag-sugti sa skilit. So, sa participants kay lima ra ka po, then sa pre-test score is lima sad. So, this data is appropriate for a dependent sample t-test because there are two groups or related data, pre-test and post-test. Two groups rin sila. The scores are numerical and measurement on the ratio skills. And that's all. This is Marchky Devinagracia. Thank you.
How to make an dependent t-test. First, understand the purpose. A dependent t-test compares the means of two related groups to determine if there is a statistically significant difference between them. Now, the question is, why use a dependent t-test? We use dependent t-test because it accounts the fact that the data are related, which reduces variability and provides more statistical power than if the two groups were treated as independent. Here's the sample. Prepare the data. To ensure the paired data, each pair represents the same participants measured under two different conditions. For example, you are testing whether a group of participants shows improvements in scores after an intervention, like the data showed in the PowerPoint. The first column contains the participant's ID. The second column, or what we call pretest, contains the data for the first condition, and the third column, which is the post-test, contains the data for the second condition. These two columns presents the two sets of data that we will compare, and each participant's data that had been showed are continuous.
Good day, sir. My name is Vergel. Is Vergel continuation of how can we interpret the result using dependent t-test? 2. Statistic. These values show how far the simple mean difference is from zero relative to the variability in the data. A larger absolute TT value indicates a more significant difference between the groups. 3. Degree of freedom. This is the number of the third observation minus 1. This is used to find the critical value in the T description. 4. Phi values. The phi values indicates the probability of observing the data, or something more extreme, if null hypothesis is true. A smaller phi value, 0.05 or your chosen significant level, suggests the difference is statistically significant. 5. Confidence interval. These range show where the true mean difference is likely to lie with a certain level of confidence, typically 95%. If the CI does not include 0, the difference is statistically significant. Step of interpret the result. 1. State of hypothesis. Null hypothesis, the mean difference is 0. Alternative hypothesis. The mean difference is not 0. Examine the phi value. Phi is less than 0.05 reject. There is a significant difference between the two conditions. Phi P is a greater than 0.05 fail to reject. There is no significance difference. 3. Review the mean difference. Look at the direction and set of the mean difference. Positive mean difference. The second condition had higher score. Negative mean difference. The first condition had higher score. 4. Check the confidence interval. If the confidence interval includes 0, the difference is statistically significant. The width of the CI indicates the precision of the estimate. 5. Contextualize the result. Interpret the result in the context of your research question. Consider the practical significance of mean difference, even if it's not statistically significant. Example, interpretation. Output from a dependent t-test. Mean differences. T-statistic. Degrees of freedom 9, p-value 95%. Interpretation. The p-value 0.38 is less than 0.05, so we reject the null hypothesis. This means there, there are is a statistically significant difference between the two conditions. The mean difference 3.2 suggests that an average score is the second condition where 3.2 points higher than in the first condition. The 95 confidence interval 0.5 5.9 does not include 0, supporting the conclusion that the difference is significant. The direction of the mean differences indicate the second condition, post-thesis and higher score. Conclusion. Conclusion. The dependent sample thesis is a powerful statistical tool used to compare the means of two relative groups, helping researchers determine whether there are significant differences between them. The thesis is particularly useful for analyzing paired data, such as pre-test and post-test score, or measuring taken under two conditions. By examining the mean difference and its statistical significance, the dependent test provides insight into whether change or intervention have unmeasurable effect. However, it is essential to ensure that assumptions such as normality of differences and absence of significant other and met of valid result. Thank you.